Hi everyone, in this video we will go over some of the challenging MCQs on synchronous machine. The first question is the per phase induced EMF of an alternator has an expression is E is equal to 10 sin omega t plus 2 cos 3 omega t plus 90 degrees. The peak value of induced EMF is options are 10 volts, option B 11.5 volts, option C 12 volts and option D 13.2 volts. Here the solution is um, uh, per phase induced EMF E is equal to 10 sin omega t plus 2 cos 3 omega t plus 90 degrees. Here EMF is given in per phase value. The question is asking that to calculate the peak value of induced EMF. Right? To find the peak value of induced EMF, we must calculate the maximum magnitude of the given expression. We know that first I am writing the expression E is equal to 10 sin omega t plus 2 cos 3 omega t plus 90 degrees. We know that cos 90 plus theta is equal to minus sin theta. It is same as that of cos 3 omega t plus 90 degrees is equal to minus sin 3 omega t, right? So, when we substitute minus sin 3 omega t in place of cos 3 omega t plus 90 degrees, the expression becomes E is equal to 10 sin omega t minus 2 sin 3 omega t, right? The peak value of E occurs when each component contributes its maximum value. Since both sine functions have amplitude of 10 and 2, the peak value is the sum of the absolute value of their coefficient. Peak value of E is equal to 10 plus 2 is equal to 12. Thus, the peak value of induced EMF E is equal to 12. So, here the correct option is C, 12.0 volts. Next question. A 4-pole generator is running at 1200 rpm. The frequency and time period of the EMF generator in its coils are respectively. Options are A 50 Hz 0.02 seconds, option B 40 Hz, 0.025 seconds, option C 300 Hz 0.00333 seconds, option D 2400 Hz 1 by 2400 seconds. Okay, here we have to find out frequency and time period of the EMF which produced in the generator. So we know that the formula of synchronous speed ns is equal to 120 f by p. By using this formula we can find out the frequency. So f is equal to ns p by 120. Now I am going to substitute ns and p values. So 1200 into 4 by 120. 0 cancel out. 12 ones are 12 tens are 120 and 4 tens are 40 Hz. Here we got frequency is equal to 40 Hz. To determine the time period, we know that t is equal to 1 by f. So here 1 by 40. By performing this division, we get 0.025 seconds. Here answer is 40 Hz, 0.025 seconds. So option B is the correct answer. Next question. The number of cycles generated in a 6-pole alternator in one revolution is. Options are 18, option B 12, option C 6 cycles per second, option D 3 cycles per second. Here in the previous question he asked to find the frequency directly. However, in this question is asking to find the number of cycles generated per revolution. So which means the frequency is being asked indirectly here. Okay, we will go to the solution. Ns is equal to 120 f by p. We know that f is equal to nsp by 120. Ns expression is in rpm. To convert rpm into rps, we need to multiply 60 with this formula. Ns value is not given, so we should take ns is equal to 1. So f is equal to 1 into 6 into 60 by 1 to 120. 0 cancel out. 6 ones are 6 twos are 12, 2 ones are 2 threes are 6, 3 ones are 3. So here f is equal to 3. Frequency is in rps. So here 3 cycles per second is generated. So option D is the correct one here. Next question. A synchronous machine has xs is equal to 1 per unit and operates at v is equal to 1 per unit. When its EMF is 1.5 per unit with load angle, current as 0.0 plus j 0.5 amps. And the mode of operation is options are generator with lagging power factor, option B generator with leading power factor, option C motor with lagging power factor, option D motor with leading power factor. Here answer. To determine the mode of operation of a synchronous machine, first calculate the generator EMF using generator EMF equation and the terminal voltage using motor equation. Then compare the result with the given data. The mode of operation correspond to the result that matches the given data. Now I am going to write a generator equation, then substitute values in this equation. Eg is equal to V plus Ia ZS. V is equal to 1 and here Ia value is given 0 plus j 0.5, so it is equal to j 0.5. Next Zs value is not given directly, but Zs are formed by r plus jx. R value is not given, so we take here r is 0 and jx x is equal to 1, so hence z became j1. So substitute all these values in this generator equation formula. So Eg is equal to 1 plus j 0.5 into j1, j into j square, j square value is equal to minus 1, 1 minus 0.5 into 1, 5 0.5 times of 1 is equal to 0.5, 1 minus 0.5. By substituting 0.5 from 1 we get 0.5 per unit. Eg is equal to, we got 0.5 per unit. This value is not matching with exact EMF value which is given in question. So this question is not belongs to operate in generator mode. Next we check the given data in motoring mode. The formula is equal to V is equal to E plus IAZS. V is equal to 1.5 plus J 0.5 into J1 is equal to V is equal to 1.5 minus 0.5. We get V is equal to 1 per unit. By solving this equation by using given data, we got some terminal voltage value which is matching with the data. So we conclude that it is operating at motoring mode with leading power factor. How we say that it is operated leading power factor? The load power factor depends on the relative phase angle between terminal voltage V and the current I. A leading power factor implies the current leads the voltage by an angle. In motoring mode, E is equal to V plus Ji, 1 plus J 0.5. Here, E has a real part of 1 and imaginary part of zero point 0.5. The internal EMF E leads the terminal voltage here. Since the current phasor I contributes positively in the J direction, it confirms that I leads V, resulting a leading power factor. So here option D is the correct one, motor with leading power factor. Next question. The EMF induced per phase in a three-phase star-connected synchronous generator having the following data. Distribution factor KD is equal to 0.955, coil span factor 0.966, frequency F is equal to 50 Hz, flux per pole is equal to 25 milliweber. It is 25 into 10 to the power of minus 3 webers. Turns per phase is equal to 240. EMF per phase is, here asking to find out EMF per phase. So EMF induced in a synchronous motor is E is equal to 4.44 kp kd pi ft. Substitute all these values into EMF equation, will get E is equal to 4.44 into 0.966 into 0.955 into 25 into 10 to the power of minus 3 into 50 into 240. Multiplying all these values, we get E is equal to 1228.81 volts. For this question, option A is the correct one. Next question. In the armature winding of an alternator, the coil span falls short of full pitch by 60 degrees. The pitch factor is, we know that pitch factor Kp is equal to cos alpha by 2. So, alpha is equal to, given that 60 degrees, by substituting 60 degrees here, cos 60 by 2, 2 ones are 2 30s are. So, cos 30 is equal to root 3 by 2. Root 3 by 2 value is 0.866. So, here option B is the correct one, 0.866. Next question. The frequency of EMF generated in a 8-pole alternator running at 900 rpm is, options are 60 Hz, option B 120 Hz, option C 30 Hz, option D 180 Hz. We know that synchronous speed formula. Alternator rotates at constant synchronous speed. Ns is equal to 120 F by P. We have to find out frequency here. So frequency is equal to Ns into P by 120. Ns here 900 into 8 pole by 12. By performing this revision, we get 60 Hz. So option A is the correct here. Next question. An alternator has rated field current of 3 amperes. It is developing 180 volts at a field current of 1.5 amperes at a rated speed. If its field current is made 3 amperes at a rated speed, then the generator voltage would be. To calculate the generator voltage when the field current is doubled from 1.5 amperes to 3 amperes, we assume the alternator operates in a linear region of its magnetic characteristics, meaning the generator voltage V is directly proportional to the field current IF. So at IF 1.5 amps, V is equal to 180 volts. At IF 3 amperes, the new voltage V should be calculated as V dash is equal to, V dash is nothing but V new value. So V dash by V is equal to IF new by IF old. By substituting the values, V dash is equal to 180 into 3 by 1.5. 1.5 ones are 1.5 times 2 times the 3. So 180 into 2 is equal to 360 volts. Thus, the generator voltage at a field current of 3 amperes would be 360 volts. Question is, the EMF induced in a conductor of a machine driven at 600 rpm, the peak value of a flux density is equal to 1 Weber per meter square. Diameter of a machine D is equal to 2 meters. Length of the machine is equal to 0.30 meters is. Here question is asking that to find out induced EMF in a conductor. So we know that to calculate the EMF induced in the conductor of the machine, we use Faraday's laws of electromagnetic induction. For a rotating machine, the induced EMF is given by E is equal to B L V sin theta. In the given question, sin theta is not included because the problem specially asks for the peak value of induced EMF, not the instantaneous value. So in this question, he already given that flux density and length values, right? First, we determine the value of velocity. Velocity defined as V is equal to pi dn. Here ns is always in rpm, so 600 is given that revolution per minute. Convert this rpm into rps, divide 600 by 60, so we will get pi into 2 into 600 by 60. 0 0 cancel out, 6 ones are 6 tens are 60, 2 tens are 20 pi. 20 pi value substitute in EMF equation. EMF equation E is equal to BLV. 1 into 0.3 into 20 pi. Multiplying all these values, we get 18.8 volts. So here answer D is the correct one. Next question. For a p-pole machine, the relation between electrical degree is, option A theta electrical is equal to 2 by p theta mechanical. Option B, theta electrical is equal to 4 by p theta mechanical. Option C, theta electrical is equal to theta mechanical. Option D, theta electrical is equal to p by 2 times of theta mechanical. Here the correct answer is D, theta electrical is equal to p by 2 times of theta mechanical.